Hello guys, this is the second video on the topic of adding and subtracting rational expressions. So I'm going to show you just some additional problems that you may work and then check with me. Okay, so here we are with 7n divided by n plus 1. And you want to add this rational expression with 8 divided by n minus 7. Okay, so I remind you that in order to add the two rational expressions, you want to find the least common denominator, and then from there you multiply and divide each of those rational expressions by a quantity that allow you to get to the same denominator, and then you simplify from there. So in this case, if you want to have the same denominator, we should multiply and divide the first one by n minus 7 and the second one by n plus 1. So this is what we're going to do. We're going to rewrite this. We're going to leave some space, and then plus 8 divided by n minus 7. So what we want to do is multiply and divide the first expression by n minus 7 and the second expression by n plus 1. Just a reminder, make sure, you don't need to write it down, but make sure that you understand why n must be different than -1 and n must be different than 7. Because if we plug in either -1 or positive 7, the denominator is going to become 0, and we cannot divide by 0, so this expression will become undefined. We don't need to write it down, but it's something you need to be aware of. Alright, so now at this point we have the same denominator, and when two expressions have the same denominator, then we can just combine the two numerators. We can add them up. So this becomes equal to, so we can draw a single fraction line with the denominator which is n plus 1 times n minus 7, and then so we can just work out the numerator. 7n times n, so we use distributive property, is going to be 7n squared. 7n times -7 is -49n, and then 8 times n is 8n, and then 8 times 1 add up to 8. So now we end up with 7n squared, and then -49n plus 8n is going to add up to -41n, and then plus 8, and all of this is divided by n plus 1 times n minus 7. That's the sum of the two rational expressions. Okay, so here is another problem. 2 divided by n plus 8, and then plus 4 divided by n plus 1. So what do you think we need to do? Alright, so we are going to multiply and divide the first one by n plus 1 and the second one by n plus 8. So now we have the same denominators. So we can draw a single fraction line. Okay, and all of this is equal to what? Well, the denominator now, which is the common one, is n plus 8 times n plus 1. So the first numerator is, here we have 2 times n times 2 plus 1 is 2n plus 2, plus second denominator from distributive property we get 4n plus 32, and now we can combine the terms. 2n plus 4n is 6n, and then 2 plus 32 is 34, so all divided by n plus 8 times n plus 1. Okay, let's see something a little bit more challenging. Alright, so here we have 5n plus 5 all divided by 5n squared plus 35n minus 40. And we need to add this with 7n divided by 3n. Okay, look at this quadratic expression. What do you think we can do with this? Well, we can factor this, but notice that before we try to use a times c, you should simplify this because there is a 5 which is a common factor here, right? In fact, and there is also a 5 here at the numerator, right? We can factor out. So what we can do is rewrite this numerator as a 5 times n plus 1. And then the denominator, if we factor out the 5, then we are left with n squared plus 7n minus 8, right? Because we multiply by 5, we come back to this. Plus, here we have a 7n divided by 3n, and as long as n is different than 0, n and n can be simplified. So we can just write this as a 7 divided by 3. Now, it is not necessary to factor this, but it looks simple to factor. We can find two numbers whose product is negative 8 and whose sum is 7, right? What are these two numbers? Well, let me simplify these two. We can simplify the 5, right? So we have n plus 1 now divided by. So these two numbers will be 8 and minus 1. So we can write this as n plus 8 times n minus 1 plus 7 over 3, right? But remember, we still need to add up these fractions, so we need to have the same denominator. So what's missing in the second expression that is instead the denominator of the first one? Well, everything is missing. It's missing the n plus 8, is missing the n plus minus 1, so we should multiply these by n plus 8 and minus 1, but then we need to do the same thing at the numerator, right? Are the two denominators equal now? Not yet. Because if you look at the first one, there is something missing here. Well, what's missing? Well, this 3 is missing, right? So we should multiply and divide this by 3. So now the denominators are the same. What we have is a single fraction line with 3 times n plus 8 times n minus 1. That's the common denominator. If I use the distributive property of the first one, we get 3n, right? 3 times n is 3n, and 3 plus 1 is 3. And then if I use the distributive property 7 and multiply by n plus 8 and n minus 1, what we get? Well, now, you already know what's this, right? Because, remember, we factor out this from n squared plus 7n minus 8. So we are not going to multiply again, right? There is no need of that. So what we should do instead is multiply the 7 by n squared plus 7n minus 8. We know we're going to get that, right, if we multiply. So now we have 3n plus 3. Let's use distributive property. 7n squared, 49n minus 56, all divided by 3 times n plus 8 times n minus 1. And let's try to combine the terms. We have a single 7n squared. 3n and 49n can be combined to 52n, and then 3n negative 56 becomes negative 53, and then all of this can be is divisible by, well, it's going to be divided by 3 times n plus 8 times n minus 1. So that's the sum of the two rational expressions. Now let me show you something a little bit different than what we have done so far, that involves still adding rational expression. Okay, how are we going to work this a problem like this? So a divided by 25 minus a divided by 5, and all of this we want to divide by a. Alright, so we need to simplify this, which means we need to combine the two numerators. So what's missing? How are we going to make the two denominators equal? I'm talking about this, right? Here I have a over 25, here I have a over 5. So what's missing in this second expression? Well, we would like to have a 25, right? But we can do that by multiplying and divide by 5. So now, the numerator becomes, so here we have a single denominator of 25. This is a, the second one is 5a, and we need to divide everything by a. So, this point, remember that dividing this by this means multiply by the reciprocal. So we can write a minus 5a divided by 25 multiplied by the reciprocal of a. A is like to say a over 1, right? Which means 1 over a. So this becomes equal to a minus 5a divided by 25a. And notice we can still simplify because we can factor out the a at the numerator to get, well, actually, I should have combined this a minus 5a earlier, right? Because we know a minus 5a is negative 4a, so we get negative 4a divided by 25a. As long as a is different than 0, we can simplify this, so we end up with negative 4 divided by 25. Okay? And then let's work this problem. Here we have 5 over 4. If we want to divide this by 5 over m minus 4 over m. Well, what can we do in this case? We have 5 over 4 at the numerator, and notice that these two denominators here, m and m, are the same, right? So we can just combine this. 5 minus 4 is 1, so this becomes 1 over m, and now we are dividing two fractions, which means multiply by the reciprocal. The reciprocal of 1 over m is m over 1, or just m, so we end up with 5m divided by 4. Okay? Alright, so there is one last problem I want to show you, you know, it's a very good problem in terms of having a general strategy to add or subtract a rational expression. So how would you adapt these two rational expressions? Something like a over b plus c over d, right? How would you do this? How would you add them up? So try by yourself first. Okay, well, we don't have numbers here, but we want to have the same denominator. So what should we do for the first fraction? What should we do for the second one? Well, for the first one, if we want the same denominator, d is missing, so we should multiply and divide by d. And the second one, we have b that is missing, so we should multiply and divide by b. So now, what we have is a times d, you know, we can just write ad, and then plus c times b is cb, and now we have a single denominator, which is bd. So yeah, that's it. We are done now, because what we have in this case is you know, a single rational expression that you know, doesn't have, you know, numbers in this case, but you can see this as a general strategy to adapt two rational expressions. Now let me show you one last problem, which is a little bit more difficult in terms of you know, there is more thinking going on, and I want you to try this by yourself first. So here is the problem. So we have 2x plus 3, and this is divided by x squared plus 3x plus 2. Okay? Alright, so we have a single rational expression. So here is the question of the problem. So what you need to do is split into a sum of two rational expressions with unlike, so different, denominators. Okay? So that's the question of the problem. Try to do it by yourself. Now, unlike denominator means you want to, of course, it would be too simple to split this into rational expression with same denominator, because you would just say 2x divided by this plus 3 divided by this, and you will be done, right? But you want to have two different denominators. Okay, so try by yourself, and then you can check with the process I'm going to show you. Okay. Okay, so how are we gonna solve this problem? So this is what I would do. I believe there is not a single strategy to do this, but I would start by factoring out the denominator into you know, product or two linear expression by using a times c. So we want to find two numbers whose product is 2 and whose sum is 3. And these two numbers should be 2 and 1, right? Which means I can rewrite this first as a 2x plus 3 divided by x plus 2 times x plus 1. Now, let me split it first with the same denominator. So now I can write this as a 2x divided by x plus 2 divided by x plus 1 also, plus 3 divided by x plus 2 divided by x plus 1. Okay? Alright. So, what can we do to rewrite this in terms of two rational expressions that have, two different denominators? Okay, well, for example, here is something we can do. Let's assume I want to write this over x plus 2, right? So just x plus 2. So I want something, let's say a divided by x plus 2. And then I want something like b divided by, so let's assume I just want x plus 1, okay? So now my goal is to find a and b, right? So once we find a and b, then we are done, right? Because we broke this down into two different expressions. Okay, so let's focus on this, okay? Now what I'm gonna do is I'm going to rewrite this, I'm gonna add them up in terms of a and b, and then compare with this expression we have here. Okay, so what we have is, and I believe there are many other strategies we can use, okay? So what we have is, so if I use distributive property here, well, what I have is a times, so x plus 1. So what I'm doing is practically add up these two expressions, okay? So this is x plus 1, and this is x plus 1, right? And this is x plus 2, and this is x plus 2, okay? All right, so now what we have is a single denominator, right? Which is, again, x plus 2 times x plus 1. And I have a times x plus 1 plus b times x plus 2, right? And now, this is equal to what? Well, if I combine this numerator, I have ax plus a plus bx plus 2b, all of these divided by x plus 2 times x plus 1. So, at this point, what I'm going to do is I'm going to focus on this part. So I'm going to compare this one with my last expression, okay? So we're going to compare these two. Alright, so by comparison, what we have? Let's take a look at only the numerator, okay? Because the denominator is the same. So I'm comparing only the numerator. So I'm comparing 2x plus 3 with all of this, right? Because my goal is to find a and b. Once I find a and b, I can rewrite in these terms, right? And we are done. So by comparison, we have that 2x must be equal to the term in x I have here. The term in x is ax plus bx, right? Which means a plus b times x is the same thing. I can say ax plus bx, or I can say a plus b times x. And then this 3 must be a plus b, a plus 2b, right? So then the 3 must be equal to a plus 2b. Alright, so remember the goal is to find a and b. Well, that's just a system of equation. Now we can simplify the first one, because if 2x must be equal to a plus b, then you want that a plus b is equal to 2, and then you want that a plus 2b is equal to 3. So system of equation 2 by 2, we should be able to solve it. If I subtract, I would do this. I would subtract the second equation from the first one, then a and a simplify to 0, right? So we can cross them out. B minus 2b is negative b, and 2 minus 3 is negative 1. Therefore, b is equal to 1. Now that we have b, we can find a. I plug it in the first one. I know that a plus b must be equal to 2, and therefore a plus 1 must be equal to 2, which means that A is equal to 1. Okay, so we found A and B, and therefore this means that I can rewrite this equation as, so remember that we wanted to split the expression as A over x plus 2 plus B over x plus 1, so we can rewrite this as, so the A and B are both 1, as just 1 over x plus 2 plus 1 over x plus 1. Okay? Alright, so just to double check that this is correct, let's add them up now. Okay, so let's do a check. So how are we going to add them up? Well, the least common denominator is x plus 1 times x plus 2. Now what I get is x, so here I multiply divide by x plus 1, so I get an x plus 1, and the second one I multiply divide by x plus 2, so I get an x plus 2, so we end up with 2x plus 3 divided by x plus 1 times x plus 2, which is exactly the same of the original expression. So this problem is a little bit more challenging because, you know, it kind of you need to work backwards from here, but you know, I hope that it makes sense to you, and I hope you consider this a good exercise in terms of understanding what adding and subtracting rational expression mean. As always, let me know if you have any question. Talk to you later.